Welcome. In this video, you'll learn about probability independent events and use it to solve problems. Two events A and B are independent if the event of one of them happening has no effect on the other. For example, rolling of a fair dice and getting 1 is probability 1/6, since there are only 1 6 on a dice out of the 6 possible outcomes. And this spinner landing on blue is 2/5, since 2 part of the 5 part is shaded blue. These two events are independent event, as the probability of rolling a dice and getting a 6 doesn't depend on whether you get blue or not on a spinner. The chances of getting 6 is always going to be 1/6 on a dice. Similarly, chances of getting blue in a spinner is independent of rolling of a dice and will always be 2/5. When two events A and B are independent, we write probability of A and B is equal to probability A times probability B. This is also known as the AND rule of probability, or we can also use the intersection symbol in place of the word and it means that if the events are independent, we can simply multiply their probabilities together to find the probability of both of them happening. So for example, if we want to find the probability of getting a 6 on a dice and a blue on a spinner, we simply multiply 1/6 with 2/5 to give 2/30. This, however, simplifies down to 1/15. If we are interested in getting 6 on a dice, blue on a spinner, and head on a fair coin, then we can simply multiply the probability of each of these events happening, as they are all independent to each other. Since probability of getting head on a fair coin is half, the probability of getting a 6 on a dice, blue on a spinner, and head on a coin is given by multiplying 1/6 with 2/5 and 1/2. This gives us 2/60, which then simplifies down to 1/30. In general, if C is another event which is independent to both A and B, then probability of getting A and B and C is equal to probability A times probability B times probability C. We can extend this rule to 3 or more independent events as well. In this question, a fair coin is tossed and a fair 6-sided dice is rolled. It then asks us to find the probability that the results are a head and a 4 in part A. Tossing up a coin and getting a head is independent to rolling a dice and getting a 4. No matter what you do with the dice, the probability of getting a head is not going to change. Coin and a dice are both fair, therefore getting a head on a coin is 1/2, as there are 2 sides to the coin and only one of them is head. Similarly, getting a 4 on a dice is 1/6, as there are 6 possible outcomes and only one of them is 4. Hence, to find the probability of head and a 4, we need to multiply the probability of head times the probability of 4, which gives us 1/12. In part B, the question asks us to find the probability of getting a head and an odd number. Odd numbers on a dice are 1, 3 and 5. So there are 3 possibilities out of 6. Therefore, probability of getting an odd number is 3 out of 6, which is equivalent to 1/2. This is also independent event to getting a head from a coin. Hence, the probability of getting head and an odd number is given by multiplying the probability of getting head and with the probability of getting the odd number, which gives us 1/4. In part C, we need to find the probability of getting a head and a square number. Square numbers on the dice are 1 and 4, so there are 2 possibilities. Therefore, getting a square number on a dice is 2 out of 6, which is also equivalent to 1/3. This event is independent to getting a head on a coin. Hence, the probability of getting a head and a square number on a dice is given by multiplying 1/2 with 2/6, which gives us 2/12 and simplifies down to 1/6. In part D, we need to find a probability of getting a tail and a prime number. 1 is not a prime number as it only has one factor, which is itself. Remember, a number is only prime when it has only 2 different factors. One of them is always 1 and the other one is always the number itself. Therefore, 2, 3 and 5 are prime number on a dice because they only have the factor of themselves and 1. Therefore, the probability of getting a prime number is 3 out of 6. Probability of getting a tail and a prime number is given by multiplying the probability of getting tail with the probability of prime number. Probability of getting tail is a half, therefore we multiply half with 3/6 to give 3/12, which simplifies down to 1/4. In part E, we need to find the probability of a tell and a multiple of 2. These two are again independent events, so we can get this by multiplying the probability of getting tell with the probability of multiples of 2. There are 3 numbers that are multiples of 2 in our dice, which are 2, 4, and 6. And therefore, we can get the probability of tell in a multiple of 2 by multiplying half with 3 over 6, which gives us again 1 over 4. Let's look at another question. Please pause the video and have a go at this question. Each letter above is written on a card. The cards are shuffled and the card is chosen randomly. The card is replaced, then another card is taken. What is the probability that both cards are letter B? There are a total of 11 cards. 2 cards have the letter B on them. Hence, choosing the first letter B from the given card is 2 out of 11. Notice that we also know after each draw, the card is then being replaced. So there are always 11 cards to draw from. Hence, choosing the second card with letter B is also going to be 2 out of 11. In order to choose 2 cards with letter B, we need to choose first card with letter B and also second card with letter B. Choosing the first card is independent event to choosing the second card with letter B. So we multiply 2 over 11 with 2 over 11 to give 4 out of 121. In part B, we need to find the probability of both cards being letter A. There are only one A in the above letter. Therefore, probability of getting A is 1 out of 11. In order to get 2 letters A's, we need to find the probability of first card is letter A and second card is letter A. So these two are independent events, so we multiply the probability of first card being letter A with the probability of second card being letter A. Since the card is being replaced, this is 1 over 11 times 1 over 11, which gives us 1 over 121. In part C, we want to find the probability of choosing one card with letter A and another one with letter T. There are one letter A and one letter T in the word probability. So the probability of getting A and T are both 1 out of 11. In order to get one A and one T, we could draw first letter T and second letter A, or other way around. We can get the first letter A and second letter T. The event getting the first letter T and second letter A is independent. Since the card is being replaced after each draw, the probability of getting first letter T and second letter A is given by multiplying 1 over 11 with 1 over 11, which is 1 out of 121. Alternatively, you could get A in the first row and T in the second row. These two are also independent events, so multiplying 1 over 11 with 1 over 11 again gives 1 over 121. However, getting T in the first row and A in the second, this event is mutually exclusive with the event getting A in the first row and T in the second. Now, if you are not familiar with mutually exclusive events, please refer to my earlier videos on mutually exclusive event. In this case, after 2 draws, you will end up with either T and A or A and T. This cannot occur at the same time. Therefore, these two are mutually exclusive events, and we can find the probability by adding 1 over 121 with 1 over 121, which is equal to 2 over 121. In part D, we are asked to find one card with letter R and another one with letter B. Since there are only one letter R out of 11 cards, probability of getting letter R is going to be therefore 1 over 11. Similarly, there are only 2 letter B's in the word probability, so the probability of getting the letter B is 2 out of 11. You can get the letter R and B in 2 different ways. You can get either R first and B second, or B first and R second. Since the card is chosen randomly and replaced, choosing the first letter R and second letter B is given by multiplying 1 over 11 with 2 over 11, which gives 2 over 121. Similarly, choosing the first letter B and second letter R is given by multiplying 2 over 11 with 1 over 11, which is also equal to 2 over 121. Since the event picking up a letter R and a B is mutually exclusive with the event picking up letter B and R, we add the 2 probabilities together. Therefore, the probability of getting one letter R and one letter B is now given by adding 2 over 121 with 2 over 121, which is equal to 4 over 121. Here is another question for you to try. Please pause the video and have a go at it. Rob and Bob each try to hit the bullseye. They have one attempt each. The events are independent. The probability that the Rob will hit the bullseye is 2 out of 3. The probability that Bob will hit the bullseye is 3 out of 4. In part A, we need to find the probability that both will hit the bullseye. Events that Rob hits the bullseye and the Bob hits the bullseye are independent. So we simply multiply the probabilities together, and which will give us 1 over 2. In part B, we need to find the probability that just one of them will hit the bullseye. This can happen one of two ways. Rob hits the bullseye, but Bob misses, and Bob hits the bullseye and Rob misses. Since Bob hits the bullseye with the probability 3 out of 4, we can also work out the probability that he misses by subtracting it from 1. And the event Rob hits the bullseye but Bob misses are independent event, so we simply multiply their probabilities to give 2 over 12. Similarly, probability that Rob misses bullseye is given by subtracting 2 over 3 from 1. Event that the Bob hits the bullseye and Rob misses are independent as well, so we will multiply these probabilities together to give us 3 over 12. And now the event that Rob hits the bullseye but Bob misses is mutually exclusive to the event that Bob hits the bullseye but Rob misses. So we add their probabilities and that will give us 5 over 12. In part C, we want to find the probability that neither will hit the bullseye. In this case, the event that Rob misses the bullseye and Bob misses the bullseye are independent. So we multiply the probabilities that Bob misses the bullseye, which is given by subtracting 2 over 3 from 1, to the event that Bob misses the bullseye, which is given by subtracting 3 over 4 from 1, and multiplying them together will give us 1 over 12. If you find this video useful for you, please click like. If you think someone else can benefit from it, please share. And if you want to hear from me again, please do not forget to subscribe to my channel. Thanks for watching. Be sure to try the exercises to test your knowledge. I'll see you in the next part.